This is accession reasoning question related to both 13th group elements and 14th group elements. And the first statement given is BCl3 involves the p-pi back bonding, but no such bonding is possible in the case of carbon tetrachloride. First, let us check out whether this statement is correct or wrong. If we consider the boron trihalides right from BF3 to Bi3, in all these cases, the central boron atom possesses only 6 valence electrons and it has a vacant p orbital. So this is electron deficient in nature and has the tendency to accept electron pair. So according to Lewis theory, all these are Lewis acids. Now when we consider this BF3, after the formation of this normal boron-fluorine bonds, the filled 2p orbital of fluorine overlaps with the vacant 2p orbital of boron in order to form a pi bond, and that is called as the back bonding, which is a p-pi bond. And the extent of back bonding decreases with the increase of size of the surrounding atom. So the back bonding is more in the case of BF3, but still it exists even in the case of BCl3 also. But the extent of back bonding is less in the case of BCl3. And what is the reason for this one? The filled 3p orbital of chlorine overlap with the vacant 2p orbital of boron in order to form that p-pi back bonding. So that is the reason why the first part of the statement is correct. But when we take the case of carbon tetrachloride, the carbon atom undergoes sp3 hybridization in the case of CCl4 and all the valence electrons of carbon are involved in bonding. So there is no chance of any vacant orbitals, and when there is no chance of any vacant orbitals and as its octet is satisfied, as it attained octet configuration, so no chance of any back bonding in the case of carbon tetrachloride. The main reason is there is no vacant orbital in the case of carbon, even though there are filled orbitals with chlorine. So the second part of the statement is also correct. No such back bonding is there in the case of carbon-chlorine bond in CCl4. Now the reason, in BCl3, boron atom has a vacant 2p orbital, but carbon of CCl4 does not. Definitely this is also a correct statement. That itself is the reason for this one. Because of the presence of vacant 2p orbital, the filled 3p orbital of chlorine can form a p-pi back bonding with the boron. But as there is no vacant orbital in the case of carbon, the filled 3p orbital of chlorine cannot form the back bonding with carbon. So here our answer is option A.